Okay, so Jeremy mentioned this comet in his talk. This is, of course, comet Aaron-Rowland from 1957. You may wonder why I've got a picture of a comet from 1957 in my Sky Notes for 2013 May. Hopefully that will become apparent a little bit later on. But this is a picture by Reggie Waterfield, and it shows even in 1957 you had the problem of aircraft flying across. It was a bigger problem in those days because this is a 20-minute exposure which he would have painstakingly taken on film, only to develop it to find that trail going across. Okay, so starting at the centre of the solar system, the Sun, we're still around solar maximum, but the Sun really, in white light, has not been particularly active, but in terms of there being large spot groups. There have been a lot of small spot groups, and Peter Meadows, who's a very keen sunspot observer, has been observing, and he says it's the highest number of groups he's seen, mean sunspot number, since November 2011. There have been some rather active groups, even though they don't look as though they're that active. This is an image by Dave Tyler of a group called AR 1748, which actually led to a large number of X-class flares. So there are 4 X-class flares from this group in a period of 2 days in the middle of this month, in May. And they led to some auroral alerts. This is one of Dave Tyler's extraordinarily good images taken in hydrogen alpha. The kind of resolution that these observers achieve is really incredible. So anyway, keep the Sun under observation. It is at solar maximum. The groups may be not large, but there are quite a few of them there to observe, and take the advantage now, because probably from next year it's going to be downwards in activity. We're entering the season when noctilucent clouds start to become visible. They've already been seen. This is a photo taken by Ken Kennedy up in Dundee a couple of days ago, actually 25th of May. So this is the time of year to see noctilucent clouds. Because the Sun is more active, they potentially are not going to be that spectacular this year, but it's worth looking out for them. Low in the northwest, the north, in the northern twilight skies. If we're lucky enough to get a nice pleasant June, it's a pleasant thing to do in the evening to look out for these things. Last year was pretty much a washout because the weather through June over most of the country was rather poor. There's also been, I had to mention the moon at some point in Sky Notes for Bill's benefit. There's been a partial eclipse of the moon, a very small partial eclipse, but this absolutely fantastic picture I actually filched from the journal. It's in the current journal, taken by Alan Tuff up in Lossiemouth, showing that very, very small partial eclipse. The weather across the country for this was very patchy. I tried to observe it from Essex, but I just had an obstinate band of cloud on the horizon, so the moon was very low. It rose basically just as it was coming out of eclipse. And again, just another example of something lunar before we move on further away. This is a picture of Clavius taken by Damien Peach. Damien's been imaging all kinds of things, and you'll see some of his images of comets later on. Whatever Damien images, he tends to be extremely good at it, and this is an extraordinarily high resolution image of that crater. It's just incredible what can be achieved these days. So what's visible planet-wise in the sky at the moment? Well, at the moment, if you have a good western horizon, you look over in the western sky, there are 3 planets on view. Jupiter, which is basically disappearing now. It's going into conjunction. It'll be in conjunction in the middle of June. Mercury, which is just rising out of the murk, maximum elongation east at the 1st of June. So it's basically a good time now to try and catch a view of that elusive planet if you get a good clear western horizon. And Venus is rising up out of the western murk, only very slowly. So over the summer months it'll be pretty much low in the twilight throughout the summer. It starts rising higher as we go into the autumn. But this is a drawing that Paul Abel sent me, made actually during daylight, so obviously it's very difficult to see details on Venus when it's only a few degrees above the horizon. So accomplished observers tend to observe it in daylight, being very careful not to point their telescopes anywhere near the sun. But there's a very it's in a gibbous phase because effectively Venus has just been through superior conjunction. You can just about see the phase there, but not a lot of detail on the cloud layers of the planet. The planet that's best visible at the moment is Saturn. It's in Virgo, not far from Spica, and if you look in the sort of late evening sky, looking due south, it's pretty much the brightest thing there. Fairly easy to find, and looks something like this if you happen to be Damien. This is one of Damien's lovely pictures of Saturn, showing a lot of detail there. So detail both in the rings and on the clouds of the planet. But one of the things that was mentioned, I think it was the last meeting when we had Mike Fultz here talking about Saturn, is an atmospheric phenomena of Saturn called the South Polar Hexagon. And if you know that it's there, you can actually see it here. So this is a hexagon around the South Pole of Saturn. Now, the tools that amateurs have available now allow them to actually take their images and project them electronically project them so that you can view the planet from any angle. So you can take this picture and you can project it like that, and there is this amazing hexagon feature in the atmosphere of Saturn. Now it's obviously some kind of standing wave feature, as Mike was explaining last time, but it's extraordinary to see something like that, and extraordinary that amateur observers can take images and process them now to show something like this. So a very interesting object, or a very interesting feature in Saturn's clouds. As far as the other planets are concerned, then basically Mars itself is not observable at the moment. It's coming out from conjunction. Mercury, as I say, is going to be briefly visible in the western sky, then will dive back down again, and Jupiter's going into conjunction. So we really have to wait until early August, so after the sort of main brighter summer months, until these planets start re-emerging in the morning sky. So early in August, Mars will start to appear in the morning sky, Mercury will be there again very low down, and Jupiter will appear, and then throughout the rest of the year these planets will move higher in the eastern sky. Uranus is over there as well too, as an object to observe. So basically, for now, I guess the real planets that we have to observe over the summer really are restricted to Saturn and potentially sort of Venus and Mercury very low in the west. Richard was talking about near-Earth asteroids, and I don't know whether this classes as near-Earth, but it's near-ish Earth. This is an asteroid that's quite large. It's going to actually come within, 0.039 AU of the Earth. It's called 1998 QE2. It should be an interesting object to observe from here. Currently it's far south, but it moves very rapidly north, and on the night of June 2-3 it goes through declination -10 in Libra, and it's got a magnitude of about mag 11, has a motion of about 20 arcseconds a minute at that point, so a reasonably fast moving object. Again, something definitely worth observing. This image here is taken with the Fultz South telescope, but by the time it's mag 11 and moving at that speed, you should be able to pick it up with a camera lens. Lots of good work being done. Richard showed some graphs. Here's another one. This is a light curve obtained by Kevin Hills of this object, showing a nice rotation period, 5.28 hour rotation period. So this is going to be an interesting object to observe. When we had the flyby of 2012 DA14 earlier in the year, we set up a BAA webcast for that object from my telescope in Chelmsford, and at one point we had 650 people looking at a blank screen because we were basically clouded out. So this is another opportunity to see one of these objects reasonably bright flying past. So going from one end of the distance scale to the other, this is an extraordinary object. This is a gamma ray burster. Now, gamma ray bursters are objects which essentially are very, very far away in the distant universe, but incredibly energetic objects that can, for a very short period, become very, very bright. And I mean very bright in absolute terms. This object became magnitude 7.4, so visible in binoculars, but only for a few minutes. It then faded rapidly down, but unlike most gamma ray bursters, which effectively fade rapidly beyond the ability of amateurs to observe them within a day or so, this one stayed reasonably bright, and by reasonably bright I mean around sort of 18th, 19th, 20th magnitude, which is certainly within the abilities of amateurs to detect these objects, reasonably bright for several days. There was an e-circular that Guy Hurst issued, a TAE Circular 2909, that basically encouraged observers to observe this, saying that the afterglow will remain bright for an extended period, and worldwide small telescope follow-up is strongly encouraged. So this GRB was associated with a supernova, SN 2013 CQ. Unlike most supernovae, though, it is at a distance that's given by this number, z equals 0.34. So what's the distance z equals 0.34? Well, this is one of those trick questions where if somebody asks you what's the most distant thing that you could see, this one not with the naked eye but with a small pair of binoculars, and people will often say something like, oh, I don't know, the Andromeda galaxy, well that's what, 2.3 million light years, something like that. Well, what's z equals 0.34? Unfortunately, to turn it into distance, you have to go into a bit of cosmology, because it's so far away that the intervening space has expanded between the time the light left the object and the time it's got to us. So there's no single answer to that question, unfortunately. But even taking the most kind of pessimistic one, which is this kind of angular diameter measurement, or the loopback time, z equals 0.34 corresponds to a distance of something like 3.5 billion light years, if that has meaning at that distance. Or the look-back time means that the light left that object 3.5 billion years ago. So only a billion years after the Earth formed. So for a few minutes, if you'd been looking in the right direction with a pair of binoculars, you could have seen something 3.5 billion light years away. So that's a nice answer to how far can you see with a small telescope. But this one was actually visible for quite some time, and David, and again this is cadged from the most recent journal, David Boyd did some observations over a number of days and got a really nice light curve here. So the red ones are, what are they called, the GCN? GCN circulars, and then the blue ones are David's observations, really nicely following that light curve. And you can see here, followed it down to below mag 20. So that's quite an impressive piece of work for an amateur. But yes, observing something basically halfway across the universe from your back garden with a small telescope. It's really one of the extraordinary things that astronomy gives us, is the ability to do that kind of thing. Couple of supernovae for Ron Arbour. I mentioned this to Tom Bowles earlier today, and I said Ron is catching him up, because Ron's got a couple more supernova, and Tom pointed out that at this current rate he'll catch him up in about 60 years. But Ron has the ability to detect these things really close to a galaxy. So there's the object, very, very close to this galaxy here. I took a confirmation image of this, and even though I knew that the supernova was there, it was pretty hard to pull it out from the galaxy. So this one is confirmed, it's a type 2P, and he's also got this one, which is still actually a preliminary designation there, but almost certainly is a supernova, but these days supernovae are being discovered almost like asteroids, and so it's quite difficult to get them confirmed. So I want to move on to the kind of main thing I want to talk about for the rest of this sky note, which is comets, and I hope you'll forgive me for doing that. Comets are the things I find really interesting, and we've also had a really interesting comet to observe. So the comet is C2011 L4 Pan-STARRS, and this comet had a really nice geometry for us. This is the orbit of the comet, this is the orbit of the Earth, and the inclination of this comet is very, very steep with relation to the Earth's orbit. So essentially it came up from south, and it then headed up to the north. So from the Earth, we've seen this comet appear from the southern hemisphere and then head towards the north pole of the sky. So it's been a good object to observe. This is the geometry on March the 12th, just as it was coming up from south of the Earth's orbit to north. And at that time, the comet was near perihelion. It was probably about magnitude 1 or so. And it was visible in the twilight sky low down in the west. And this is a really nice image by David Strange on the 17th of March, which shows it with this, which is its dust tail, and in fact the dust tail extends quite a long way here, and just a really nice view of a comet in a twilight sky, something you don't see very often. So the comet continued on up in its orbit, going basically further and further above the Earth's ecliptic plane, and you can see from the geometry here that essentially the sun's here, the comet's here, the Earth's here. So the sun is basically, sunlight is pushing dust from the comet out into a tail, which is essentially, we're seeing almost projected behind the comet. So the comet took on a very strange appearance, and this is an image by Damien using a remote telescope taken on the 9th of May. So what you've got here is, this is the coma. You've got a huge dust fan, so basically everything on the right hand of this image is bright compared to the dark sky here. And what this is dust that's been thrown out from the comet to form the tail, but that we're actually seeing almost, we're almost looking down the tail. So the tail is projected away into the screen here, and we're seeing it highly foreshortened. So what we're seeing is a very large dust fan projected against the sky. So this very, very unusual view for a comet. And in fact, in wider field images, this dust fan is absolutely enormous. We saw it earlier on in April when the comet, a lot of people saw the comet as it was passing M31, the Andromeda Galaxy. And at that time it was a large fan. But the fan just extended, and the angle between the edge of the fan extended further and further as the comet went further and further north of the ecliptic, as we saw, as the geometry changed. One other thing to note is a feature that was seen in the comet right really from sort of early April onwards, and that is this brighter ray up here on this edge of the fan. Now this brighter ray is actually dust that's in the plane of the comet's orbit, and we'll see that develop as we go through towards late May. So here's another image. This is taken middle of May. Damien Peach, a wider angle image, and again you see this very diffuse dust tail, but this ray here now extending, and at the time this image was taken, this ray was something like a degree or so long. This dust fan again was enormous, went out several degrees. So the ray just got bigger and bigger and bigger. This is an image taken by Martin Mobley with a remote telescope on May 21st, so only a week or so ago now. And you can see the ray effectively going out of the image here. The dust fan itself was becoming less and less obvious. So essentially what you were left with was this coma feature and this very extended ray, which is dust in the plane of the comet's orbit. And the reason that this was becoming more and more prominent was that the geometry was changing so that the Earth was approaching a position where it essentially was in the plane of the comet's orbit. So this is the situation on May the 26th. This is the comet's orbit. The comet had come down here, gone back up there, and was now well above the ecliptic. And the Earth was approaching a point where, if we look at it from a different angle here, where essentially the Earth passed through the plane of the orbit of comet Pan-STARRS. Now, this had happened before with Aaron Rowland, so we knew what to expect, but we still didn't expect it to be quite as spectacular as it was. So this is an image taken on May the 26th. It's actually a picture I took with a 100mm lens on a DSLR camera. So what you've got here is at this time the comet was very far north. So this is Polaris. There's a little open cluster here called NGC 188, so I do get some deep sky stuff in, just in case I get complained about. And here is the comet. So here's the head of the comet here. The wide dust fan has pretty much disappeared. There's a kind of conventional tail, but it's very puny and very small. But what you've got is this spike here, which is something like 8 degrees long. Really amazing thing. I mean, I'd been seeing the pictures of this spike getting larger and larger and larger, and we were very lucky. This was last Sunday night. We were very lucky over the UK that it was a good clear night. We were unlucky that the moon was full, but there wasn't really much we could do about that. But with enough images, and this is actually 61-minute images stacked up, this actually goes off, and you can't quite see it, but it goes off, sort of fades into nothingness around here, but it's about 8 degrees long, this spike. A couple more images here. So the top one is is a mosaic that I made with a Megaris 72 and a SXHV9, is it, I think, something like that. Anyway, it's a mosaic of 6 frames. Each of these frames is just over 1 degree in length. And again, you can see the effect of this spike disappearing off down here. This is NGC 188 here, and this just fading off into the distance. On the same night, or just a couple of hours later, Martin from New Mexico obtained a higher resolution image. So this is basically the first degree and a bit or so of this dust spike. So there's been a lot of speculation about how this compares with the famous spike of Aaron Rowland. So this is Aaron Rowland, 1957. This is an image that Reggie Waterfield took in April 1957, on the 26th of April. The 26th of April was very near to the point where the Earth went through the orbital plane of Aaron Rowland. It was a rather different situation then, because Aaron Rowland had only shortly been through perihelion. It had a conventional, nice, big tail. So this is actually Perseus. So this is Murphak here, and this is Algol, just to give you an idea of the scale. Conventional, nice, big tail, but also it had this very bright spike. And of course, Aaron Rowland is famous in this country as being the first comet that was really reported on in the sky at night, because the sky at night started in April 1957, just as this comet was at its very best. But there's been a lot of speculation as to whether Pan-STARRS actually beat Aaron Rowland in terms of the spike length. And it didn't quite, as far as we can tell, although it is very difficult to be sure about that because we had to contend with the full moon. But the images that were taken in April 1957 of Aaron Rowland, there are some images that were taken by an observer at the Uppsala Observatory in Sweden. And those images showed the sunward tail of about 13 degrees long. So it is probable that the Pan-STARRS anomalous tail is not quite as big as the Aaron Rowland anomalous tail is. But we've essentially had to wait almost 50 years to have a sort of reproduction of what happened in this case. Everyone, I mean, I've been many years, of course, known about Aaron Rowland, looking at photos of it, thinking whether we'd ever see anything similar. And we have now, with Pan-STARRS, seen something similar, except the Pan-STARRS didn't actually have a normal tail. All it had was the anomalous tail going along the plane of the orbit. So, again, as a comet observer, I found Comet Pan-STARRS to be an extremely fascinating object to observe. Some people say it didn't live up to early expectations, or that it wasn't really spectacular. I would completely disagree. I think it's a comet that's basically had everything. It's been a comet that you've been able to see in the twilight sky, a comet that's had a very impressive tail, a comet that's passed by various interesting deep sky objects, and a comet that's had this extraordinary anomalous tail as well. Basically, this little tiny nucleus has thrown out a huge amount of dust. In order to generate this tail and this anomalous tail, it must have thrown out a huge amount of dust. Work that Richard Miles has done doing photometry of this object has shown that in terms of its behaviour, it's been an extremely well-behaved comet. So it's been throwing out dust, but it's been doing it continuously and regularly. It hasn't had any outbursts or anything else. So it's still visible, still worth following. It's basically going to be moving through pretty much the rest of the year. It's currently about magnitude 8, 8.5 or so. The anomalous tail is getting less and less bright as we come out of the orbital plane. And what we should see is the reappearance of the big dust fan again, as we see it essentially projected in the other direction as we come out of the orbital plane. So it's definitely worth keeping an eye on. And it should keep us busy for a little while until maybe this one does something interesting. So this is the next comet that could potentially be something interesting in our skies. This is C2012S1 ISON. This is the one that had been reported in the media when it was first discovered that maybe it would be brighter than the full moon. To paraphrase Patrick Moore, we just don't know. This comet photometrically has been quite stable recently. It's not been brightening as some people had hoped, but it's so far out in the solar system, it's still 4 AU out, that really we can't make too many predictions about it. But it'll still be an interesting comet to observe, as all comets are, and that's why I find them interesting, because you never know quite what you're going to see. It's like Jeremy going out looking for these outbursting CVs. When you go and look at a comet, you never quite know what it is you're going to see. There is one thing we can predict about it, though, and that's its orbit. We know its orbit extremely well, and we know that we are going to go through the plane of the orbit of C2012S1 on January the 16th, 2014, when it's not far after perihelion, and this is a comet that gets very, very close to the Sun at perihelion. So if this comet does a breakup or throws out a lot of dust or something like that, we have the potential of seeing another of these very interesting anomalous tail events in the middle of January 2014. So there's a prediction for you, which we can see whether it comes true next year, about possibly an interesting anti-tail on 2012S1 in the middle of January. So just finally, one thing that Richard Miles, when he was talking about 1998 QE2 to me a couple of days ago, mentioned, which is one of the things I find extremely irritating, and that is that it doesn't seem possible in the media these days to report the size or the velocity or the mass of something using proper units. It always has to be in terms of the area of Wales or the length of double-decker buses, or I saw something about Niagara Falls being so many Olympic-sized swimming pools of water per hour. So I get extremely annoyed by that. But you can understand why the media do it. This, though, actually came in a press release from JPL. They have the neat idea that this asteroid is 1998 QE2, so why not measure its size in terms of the length of the real QE2? So just in case you can't cope with kilometres, you can remember the size of this object is actually 9 QE2s long. Thank you very much.